Okay, so last lesson we're going to look at is 6.3, third part, still graphing sine and cosine. We are going to get into graphs of other trig functions like tangent, cotangent, but that's section 6.4. Okay, so we'll do that when you come back after break. So remember the order that we always follow. Okay? I'm going to write it down as an equation and use the letters I've been using all week. Y equals C sine dx plus A plus D. Now it could be plus or minus D, it could be plus or minus A. It just depends on which way you're shifting. So I can put that in. And it could be sine or it could be cosine. Either fine. The A is the first thing that you do. When you add or subtract inside the parentheses, what kind of transformation is that?
Horizontal shift.
Horizontal shift, and we call that a phase. Second thing is B. Multiply inside the parentheses. What happens when you multiply inside the parentheses?
Horizontal shrink or stretch.
Horizontal shrink or stretch, and that changes the period, so we call it a period change. The third thing is C. That's multiplying on the outside. What happens when you multiply on the outside? What kind of transformation? Chris?
Vertical stretch or shrink.
Yep, vertical stretch or shrink. And the last one is D, and that's when you add or subtract on the outside. What does adding or subtracting on the outside do? Yeah, Alex.
Makes it vertical.
Vertical shift, up or down. Those are your four transformations. Those are the orders you do them in. Now, if B or C was negative, what does that cause? We're not really doing B negative, but if it was, what does a negative cause the graph to do? Flip. Okay. Probably not going to give you a problem with every one of these in the same problem, but you may have two. I think we do one with three. So here's our first one. 2 sine x plus pi over 2. Just make sure we know what they're doing first. What's the plus pi over 2 going to do? What kind of transformation? Phase shift. Yep. And what's the 2 going to do? Chris? Yep. Vertical stretch. All right. So we have to do them in that order. So for now, pretend like the 2 is not even there. Right? So first problem we're going to do is sine x plus pi over 2. I'm just going to do that problem. We'll come back to the 2 after. Okay, for a phase shift, can somebody remind me which column is unaffected? Stays the same. The y's. So I'm going to write down my y's for sine. Emily, what are my y values for sine?
0, 1, 0, 1, 0.
Perfect. 0, 1, 0, negative 1, 0. Now, on the outside of this box, I'm going to put my original x's. Sam, what are my original x values for sine?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep. Now, it says plus pi over 2. What am I going to do to all those values? Okay. Yep, we're going to minus pi over 2. Okay, I'm just showing you the work. What I'm actually going to grade on a problem like this is the final answer. We haven't even gotten to that yet. Right? This is like an intermediate answer. It's step 1, and then we got to do step 2. So 0 minus pi over 2 is negative pi over 2. Eric, what's pi over 2 minus pi over 2? 0. Jacob, pi minus pi over 2?
Pi over 2.
Yep. So again, if you need to find common denominators, that's fine. If you notice the pattern, that's fine. I don't care which way you do it. Zach, what about 3 pi over 2 minus 1 pi over 2? Yeah, it would be 2 pi over 2, which is just pi. And Chris, 2 pi minus 1 pi over 2.
I over 2.
Yeah, good job. Nice. Okay, so now don't graph that. We're not done. We're going to use that table to now do my next transformation, which is the 2. So now we're going to do y equals 2 sine x plus pi over 2. Now, don't go back to the original table in your notes from Monday. Use this table. Okay? We said 2 is a vertical stretch. So, Kaya, which column is not affected when we do a vertical stretch? No, y's are vertical. So the y's are going to all change. The x's are going to stay the same, right? Because we're not going to do anything else horizontal in this problem, right? So x's stay the same. Copy those down. This is what I will be grading, the table that you're putting right here. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Now, I've got my original y values for sine. Caleb, what am I going to do to all those y values?
Do divide by
Can you say it one more time?
divide by half.
Okay, you could. What's that the same as doing? I think that's more confusing to think of it that way.
Divide by 2.
No, divide by half, divide by 2 aren't the same.
Yeah, that's multiply by.
Multiply by 2. Yeah, you just take the number that's in front and you multiply everything by that number, just the way it is. So double all your y values. 0, 2, 0, negative 2, 0. 0, 2, 0, negative 2, 0. And that is what I would be grading. Okay, just like every other problem, you're going to get 1 point for each x and y you get corrected in the table. Now we make our sketch. All right, so I'm going to go 0, 2, negative 2. And for my x values, those x values are all nicely spaced. If they were in degrees, I think everybody would see that easier. Negative 90, 0, 90, 180, 270. They're all 90 apart. Okay, so let's put those as our labels. Negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Last thing, put your sketch. 0, 2, 0, negative 2, 0. 0, 2, 0, negative 2, 0. Done. There's your graph. Okay, so that's a multi-step problem. I don't really think it's that much harder than a single-step problem. I think it's longer. You have to do two things in the same problem. Now, technically, if we look at that, how many transformations did you do to the x column? 1. How many did you do to the y column? 1. You did 2 transformations, but they were on separate axes. Technically, if the transformations you're doing are on separate axes, you can do them in either order, because you're just doing one thing to the x's and one thing to the y's. Where you start to run into a problem is if you do 2 things on the same axis, like a vertical stretch and a vertical shift. Then the order starts to make a huge difference, right? If you stick to that all the time and don't try to guess when you have to follow it and when you don't have to, you'll be okay. So I would just stick with that order all the time. All right, let's try this one. 3 cosine 2x. What number am I going to focus on first as my first transformation? The 3 or the 2? The 2. So let's make a table of that, cosine 2x. Okay, how about Eric? What kind of transformation is that?
It's going to be a horizontal
Yep.
Shrink.
Yeah, that's going to be a shrink. That's our period change. It's going to shrink horizontally. Horizontal is the x's. So x's are going to change, y's stay the same. Jacob, what are my y values for cosine?
One zero negative 101.
Yep. All right. I'm going to put down my original x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. And Zach, what am I going to do to all those x values to get my new ones?
Divided by 3.
Yep, divide by 2, which is the same as,
1 by a half.
yep, take half. All right. So I'll multiply all of these by a half. And Chris, can you tell me what I get when I multiply all those by a half?
You got 0.
Yep.
One. 4.
Pi over 4.
Pi
Yep.
over 4. Pi over.
Yep. Pi over 2. So multiply straight, go straight across.
3.
3 pi in the top.
4. 3 pi.
Yep. And the last one? 1 pi. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. There's your math. Okay, so there's the first part. Now we got to deal with the 3. So next transformation. Okay. Elias, what's the 3 going to do?
The 3 is going to cause horizontal shift.
So shifting would always be addition or subtraction. Horizontal would always be inside the parentheses. Vertical stretch. So just like this one where you had the 2 on the outside, now you get the 3 on the outside. That's a vertical stretch. So K, a vertical stretch. Which column is going to stay the same?
Y.
So think about which way the y-axis goes. Yeah. For a vertical stretch, the y's are going to change. X's will stay the same. Okay, so write down your x's. 0, pi over 4, pi over 2, 3 pi over 4, pi. Now, if you look at those in degrees, they are all nicely spaced. That's 0, 45, 90, 135, 180. They're all 45 apart. Normally, they're all 90 apart. You've divided the distance they're normally apart by 2. You compressed it. Okay. So we got that. And Emily, what am I going to do to all my old y values to get the new ones? Yep. So can you tell me my final y values?
3 0 negative 0 3.
Yep. There you go. So 10 points for the numbers in that table. And now a point if we get the sketch. All right, so I'm going to go 0, 3, negative 3 for my scale. And I'm going to go 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But I reduce as I go. Okay. 3, 0, negative 3, 0, 3. 3, 0, negative 3, 0, 3. Here's your sketch. Okay, any questions on that one? Okay, so we did a shift, a horizontal shift, vertical stretch. We did a horizontal stretch with a vertical stretch. I don't know, does anyone want to see one more of those? No. That one would be both on the same axis. That's a horizontal shift and a horizontal stretch. So the order would be very important. Which one would you do first? Yep.
The pi over 2.
You deal with the pi over 2, which is going to shift everything to the
Right.
It's going to shift everything to the right, because that's negative. Yep. And then the 3, that's going to be a compression by a factor of 3. It'll be pretty much the same. All right, so this is a calculator question, because it says find the complete graph. Well, at least that part of it is. Then it asks to find the domain, range, amplitude, and period. All right. Now, when you graph it, sometimes they'll say graph it and show 2 cycles or show 3 cycles. If they say that, the first thing you have to figure out is the period. If you figure out how long one cycle is, then you can figure out how long any number of cycles are. What's the formula to find the period for sine or cosine? Starts out with t equals.
Is it t equals pi over c?
Not quite, Nikira.
2 pi over b.
2 pi over b, where b is the number in front of x. So the period here is 2 pi over 3. So now, I want to graph that. Actually, no, we can figure out a few more things first. Let's do the amplitude. What's the amplitude of that graph?
4.
4. Yep. Okay, and the other stuff, it would be helpful to have a visual. Okay, I want to show 2 cycles of that graph for sine 3x. So, can anybody tell me what the width is for sine 3x? What would the width have to be of my window in order to show 2 cycles? That?
4 pi over.
Yep. It'd be double 1 cycle. So, one way to set a window of 4 pi over 3 is to go 0 to 4 pi over 3, like that. Now, you could go 4 pi over 3 to 8 pi over 3. You could do 8 pi over 3 to 12 pi over 3. You could set anything you want as long as the difference between the min and the max is 4 pi over 3. Right, let's hit graph and see what we got. There's 1 full cycle, 1 1/4, 1 1/2, 3/4, and 2 full cycles. All right. So we've got the period, we've got the amplitude. Let's do the domain. What's the domain of that graph? Yeah, goes forever, left and right. You never have to pick your pencil up to draw it left and right forever. So what that means is you can plug any value you want in for x, triple it, and then take the sign of it. You'll never get an error or anything like that. So domain, negative infinity to infinity. How about the range? What's the range going to be, Emily? -4 to 4, including or not including? Including, because normally sine is -1 to 1. You've quadrupled the height. So now it's -4 to 4. Okay. So we found everything they wanted, and we did a complete graph showing 2 cycles. Questions on that? All right, so go this one. Find a complete graph again, and then the domain, range, period, and amplitude. Let's start with domain. You shouldn't really ever have to think about domain too much. What's the domain? Jared?
3 to -3 included.
So you're saying the graph will never go?
No, negative infinity to infinity.
Yeah. For sine and cosine, the domain is always negative infinity to infinity. For tangent, cotangent, secant, cosecant, no. That's it. So we get domain. Now, what were you saying? What else were you saying, Jared?
Including -3 to 3 included.
Right. Amplitude here is -3 to 3. I'm sorry, not amplitude. Range. Sam, how about what's the amplitude?
3.
Absolute value of the number in front. And what's my Kara, what's my period here?
5 and 9.
So the period is a length, so it always has to be a positive number. Tell me, what's B in this case? That's A. -1 is a phase shift. Where do you look for B? You always look where?
In front of the x.
In front of the x. So what's in front of the x?
1.
1. Yep. So in this case, the period is 2 pi divided by 1. Or just 2 pi. Okay, so let's graph it. Let's show 3 cycles. What has to be the width of my window if I want to show 3 cycles? I just pick 3. Yeah. 6 pi. So set any window you want as long as the difference between the min and the max is 6 pi. That's one way to do it. Right, now we got to type it in. 3 sine x minus 1. We've done everything right. You should see exactly 3 cycles. And you will. It's 2 and 3. Okay. Any questions on that? So, the last thing we're going to look at is solving trig equations on the calculator. Now, I'm going to show you how to do it graphically. Graphically, not the fastest way to do this problem. If I had to solve this problem really quick by hand, the way I would do it is I would cancel out the sine function by using something we don't know yet, but we're going to learn about in 6.5, called inverse sine. If I take the inverse sine of each side, that would cancel out sine, and x would be the inverse sine of 0.4. That's one of my answers. Notice I said one of my answers. There's going to be 2. The other answer would be pi minus the first one. Now, I just did that whole problem. We're not going to do it that way yet. But I wanted just to show you how quickly I can do it algebraically compared to how much slower it's going to be graphically. All right? But keep those 2 numbers in mind, and we'll come back to it. All right, so the way we're going to do this graphically, what do you think I could put in y1?
0. Or 0.
Not 0. Yep.
Sine x minus 4.
You could move everything to one side, yep, and you could calculate a root. Or you can leave it the way it is and use y1 and y2. You can do it either way, it doesn't make a difference. Since Zach said that, I'm going to bring everything to one side. Sine x minus 0.4 equals 0. Now we're looking for where it crosses the x-axis. Okay, let's do it. So, sine x, important you close that parenthesis, minus 0.4. Now, it's a wave. The wave goes on forever. Where is it going to hit the x-axis? It's going to hit it a bunch of places. It's going to keep hitting it forever. But they specifically said to just give the answers between 0 and 2 pi. So that's what I will do. And what's the name of the feature if you want to calculate where it crosses the x-axis? Yeah?
0.
Yep. Second calc, 0. I'm going to pick a value to the left. I'm going to pick a value to the right. I'm going to hit enter. And look what I get. 2.73. Now, remember the answer that I had on the screen. 2.73. So I'm not saying graphically is bad, it's fine. It's a lot slower than what I did. But it required me to know a few more things. You have to know, well, why did I minus my answer from pi? Why did I do that? There's a reason why I did that. Sometimes I add it to pi. Sometimes I subtract it from pi. Sometimes I subtract it from 2 pi. Depends on which quadrant you're in. Right? We're going to learn that more in, I think it's section 6.4 or 6.5. We learn more about that. Now, if I did second calc 0, I would also get 0.411 as the other, or 0.412. Does anyone need me to go through and show you how to do the other one? You would get 0.411. Right. So, 2 answers. 0.41, it actually rounds up, 412. And 2.73. And if you're looking at that and you're saying, well, yeah, but is it going to cross again, like right over here somewhere? Yes, but they don't want to know that. They specifically said to you 0 to 2 pi. And notice the other thing about how they wrote that. They included 0, but they didn't include 2 pi because the left edge of your window is really, if you're showing one cycle, is a repeat of the right edge, like the very edge. So if you're showing one cycle, you don't include both edges. Right? It's kind of like including 0 and 360. That's the same angle, 0 and 360. So you go from 0 up to like 359.9 repeating. Don't include 360. Okay? Only include one edge of your screen. All right, let's do this one. Someone give me a different way to do this one besides the way Zach said the first time. But still graphical.
Graph 2 lines, one that's 2 cosine half x, and one that's 1.5.
Yep, 2 cosine. It's just easier for me to type 0.5x so I don't have to use the fraction. So I've got that. I've got that. And that's impossible. So it should be the same as the other one. Okay, so window's already set. Equation's set. Let's hit graph. How many solutions does this one have? Just one. Could have one, it could have 2. It depends. It depends on what your graph is. And we're going to do what Zach said. Second calc, intersect, enter, enter, enter. And here's your answer. 1.445. Questions on that one? Okay. Again, unless you really want to focus on doing things graphically, which is what I want to do in this section, there is no reason to solve that problem graphically. I could solve that much faster using algebra. First, dividing by 2, then taking an inverse cosine, and then multiplying each side by 2. If I did those 3 things in that order, I could get x by itself. Okay. We get this one, and that's it. Right, let's do the same thing here. Let's do it just like we did the last one. Let's do a y1, y2, and then find an intersect. So Sam, what's going to go in y1?
3 cosine half x.
Yep, doesn't matter which side you put in y1, just put one side. And Caleb, y2?
2 sine
2 sine x. Window's good, 0 to 2 pi. And let's see how many solutions these have. Okay, so look at it carefully. How many times do those graphs cross?
3 times.
Yep, they cross 3 times. So, second, calc, intersect. This is where moving your cursor closer to the one you want is important. So I'm going to start with the one that's right about there. And I get that one. Next, I'm going to do the middle one. And I'm going to move my cursor closer to the middle. 3.14. Get that one. And third one. Second, calc, intersect. And move your cursor closer to the third one. Okay, so those are your 3 answers. Okay, any questions on that? Now, that one could be a little tricky to solve for algebraically. We are going to look, I think, in chapter 7 or 8 at solving equations algebraically, but they have to work out special. Like it has to work out where you can use like factoring or quadratic formula. And you might think at first, like, well, what do you mean like quadratic formula? Well, if you had something like this, 2x squared plus 3x minus 4 equals 0. If you know how to solve that with quadratic formula, then you know how to solve this. 2 sine squared plus 3 sine minus 4 equals 0. That's the same problem. It's exactly the same problem. 2 times something squared plus 3 times something minus 4. 2 times something squared plus 3 times something minus 4. Right? There's one extra step at the end of a problem like that, but you can still use quadratic formula on a problem just like that. A is 2, B is 3, C is -4. Go to town. That's it. Right? So we will talk about how to solve some special equations later on. Okay. Any questions on this one? Let's look at the last one. What's different about this one compared to the ones we've been solving on the calculator so far?
It's an inequality sign.
It's an inequality. So when you write your answer, it's not going to be x equals like 2.6. Your answer is going to be what?
X is greater than.
Right. It's going to be an integral. X is greater than 3 and less than 4, or something like that. So you can solve this using the same technique we've done. y1, y2. 2 cosine x and -1.3. Window is 0 to 2 pi. 0 to 2 pi is pretty common. So once you set that, usually that doesn't change a lot. It could, so read the directions on the test. And you're looking for where the cosine function is above -1.3. How many spots is the cosine function above -1.3? How many sections or section if it's only one? 2. Yeah. From highlight in green what we want. There to there, and there to there. So describe those two sections in green for me. We can do a little bit before we use the calculator again. Where does the first section in green start?
Like,
Less than 1.
oh, 0.
0. Yeah. Section in green starts at 0. Remember, you're focusing on the x value. Including or not including 0? Including. Can you tell me why, Chris? Because of this right here. Including. So, we call this interval 1. Interval 1 is from 0 up to. Now, I'm going to have to figure out what that is. How am I going to figure this out? Well, besides Chris or Jared's, they just answered a couple. How are we going to. What's that?
Use the calculator.
And do what?
Just see where it intersects.
Yes. Calculate the intersect. Second calc, intersect. Okay, so I've got the intersect, 2.28. Can someone finish off this interval for me now? What's going to go right there? Yeah? Why parenthesis? Why not bracket? Doesn't have the equal sign right there. Okay, so that's interval 1. Or, how's my next interval going to start? Bracket or parenthesis? Parenthesis. So technically we're not including that, so I should really make that like an open circle if we want to be picky. So, open. And how is my interval going to end? Bracket or parenthesis? Right. You're not including the last number. And what's the end of this interval? 2 pi. Now all I have to do is find the intersect of that one. All right. So, second calc, intersect. Once you're more than halfway towards it, I think you're good. It'll gravitate towards that one. 4.00. And that's interval 2. So that's your answer. From 0 to 2.28 and from 4 to 2 pi is where the cosine is above negative 1.3. Okay. If they wanted to know where it was below, you would just say from 2.28 to 4. That's where it's below. Okay, any questions on that? All right. So, for the test tomorrow. Some things that you want to make sure you know. Graph. It's pretty much what we did all week. So graphs of sine and cosine. We want to know how to do the 4 individual transformations and multi-step. So I'll probably give you one phase shift, one vertical shift, one horizontal stretch, one vertical stretch, and I'll give you one multi-step. You should know how to calculate period and amplitude. We did that in a couple problems where we found domain, range, period, amplitude. What else? you should also know how to solve trig equations on the calculator. Actually, I'll put trig equations or inequalities on calculator. Now, what can come up with that is, let's say I had something like this. Sine x equals, let's say, a half. Right? And you go to solve this. Well, let's say I gave you choices of something like pi, 3 pi over 2, pi over 3, pi over 6. When you do this on the calculator, what kind of answer is the calculator going to give you?
Decimal.
It's going to give you a decimal, right? So I'm not going to graph it. I'm just going to save time and do this the quick way. I'm going to take the inverse sine of 0.5. But if you graph in y1 and y2, you get the decimal 0.523598, all that stuff. How can you figure out which one that matches up to? Calculate all those out. It's not this one. It's not 3.14. Anyone have a guess which one it is? Yep. Yep, it's D. 3 pi over 2 is 4.71. Pi divided by 3, well, pi is almost 3. If you take 3 and divide by 3, you basically get 1. So that's a little bigger than 1. But if you take pi and divide by 6, you get 0.5235. So that's the one it was. Right? So you may have to take an answer that's written as a fraction with pi and change it to a decimal. All right. And that's it. That's everything that's on the test. So mostly graphing. I think there's 5 graphing problems, and those are going to be worth 55 points. So this part right here, pretty sure that's worth 55 points. 5 questions at 11 points each. And then this part, I think there are 9 questions. And if I make each one of those worth 5 points, 9 times 5 is 45.
Are we allowed to have a reference sheet?
Yes, you can have a reference sheet. Okay, so that's everything that's on the test. All right, so you guys have got about 25 minutes left. That's the homework, page 346. There's some extra books if you want to get started on that, so you don't have as much to do tonight. If you want to work on your reference sheet, you can do that too. But please try to do something within 25 minutes here.